seen by the edge. And of course the version is the OS version. Let's select one of these devices and dig in deeper to the Monitor Network section. In this first section, you can see many rudimentary statuses for the devices, such as how many times they've been rebooted, if a USB is being used. In this case, you can see there are no USBs in the USB port. You can see that there are 2 power supplies, but only one of them are plugged in. You can also see that the fans are operational. So again, this is rudimentary information. If I click on interfaces, the interfaces charts are representative of the bidirectional utilization of various WAN and LAN ports on the device. One thing to note, at the bottom section where you see the 6 check marks, the green check marks on the left, those check marks don't mean that those devices are turned on or those ports are turned on. It actually means it shows you what is being shown in the chart above. So if I deselect one of them, it will take that out of the chart above, and so I can select only 6 at a time. Notice if I deselect the bottom one, it'll remove it from the chart above, and then I'll select a different one and it will put it into the chart above. Now let's click on T-Lock and take a look at the T-Lock section. The color is a tag assigned to the WAN circuit that terminates on a given device. The color utilized within the PoV pods are MPLS and Private 1. Private 1 is our internet for the PoVs. In a production environment, the color tagging is dependent on the types of circuits that will be used or obtained. It is common to observe public internet and LTE as color tags used for circuits. For the purposes of this pod, the color tags have been selected based on an IP connectivity of the circuits in the environment. The MPLS tag is for the circuit that simulates the MPLS VPN. The Private 1 connection simulates devices that reside behind a common NAT to get to the internet, which is a shared circuit for these PoVs. For this particular device, with no policies enacted, meaning we're in default state, you can see that all of the tunnels are up in the status field with the up green arrows. We will talk more about these statuses in a future video for policies. A T-Lock is an abstraction for a tunnel endpoint. The T-Lock is made up of a system IP to uniquely identify which device, the color that identifies which circuit on the device, and the encapsulation, the tunnel method being used. Combined together, you obtain a T-Lock, or a transport locator, which acts as the tunneling endpoint and has attributes that can be manipulated to alter the flow of traffic. Notice in the output we have 4 MPLS tunnels and only 3 Internet Private 1 tunnels. If you look at the topology drawing for this lab, you will notice that Site 4 MPLS edge is not connected directly to the Internet, hence the fact that you don't see a Site 4 MPLS edge in a list of Private 1 tunnels. Control connections show the various connections from each V-edge to the controller in the cloud. For high availability, each edge will be built control connection to vSmart over every T-Lock. The vManage connection is, however, built over one transport to allow control of which circuit is used to send telemetry data to the vManage for monitoring and operations. In case of failure, the path of which the vManage connection is established, the vManage connection will move to the other circuit. If you notice in this output, vSmart is on both paths, and that's because it uses very little traffic. But vManage uses a lot more traffic, so it's only on one path. If that path was to fail, the vManage would move to the other path. If we click on the Events button, you will notice that we have various different logging that happens in the events, and that is everything from software updates to routing updates to users logging in and out. Next, second from the bottom, is troubleshooting. Let's click on there and see what's inside. First of all, let's start with the device bring-up. The device bring-up page is a convenient reference page to identify where a given device is in the sequence for being fully operational. We can see if a device has been authorized by an administrator and successfully authenticated by VBON. If so, we may proceed further for code upgrade if migrated, then receiving its full routing configuration if the template has been specified. Once a device has a full configuration, it establishes a connection to the vSmart and advertises the routes, security associations, and services to the vSmart. Based on the policies of the vSmart, it is then informed what data plane connections to establish, assuming it's in valid mode and not staging mode, and becomes a member of the overlay after that. If I click on troubleshooting in the breadcrumbs above, it'll take me back to the previous screen. Then I can click on another troubleshooting tool, such as ping. Once I'm at the ping page, I can put in my destination IP and click ping, but there is other advanced settings such as source interface and various other advanced settings that I can set for ping. For now, let's just go ahead and put in an address, put in VPN 0, which should fail, and then click ping. As you can see, we now have results of our VPN 0 ping. Be very careful when looking at the results. When you first look at it, you might think that the pings were successful because you see all the data there. But if you notice, they're all sends and we have not got any receives. Now let's set that same ping to VPN 1 and see what the results are. With this successful ping, you can see that we have sends and receives. You can see that we have 4 received and 1 was lost, and that's due to ARP. Next, we're going to go to Monitor Events in the main navigation on the left. The difference between this events and the one that we saw under Network was the one under Network only showed us one vEdge at a time, where this output shows us the events for all of the devices on the network. You can filter on these items such as severity or system IP, or drill down to events and look for certain information. Next, we'll go to Monitor Alarms. And in the Alarms section, all of the severe or disruptive events will get rolled up into the alarms display. If we go to Monitor Audit Logs, this will show us who made what changes. As you can see, I've made quite a few changes on the system. Another great troubleshooting command is to go to the Tools, Optional Commands, and then select one of your devices and go to the More Action icon on the far right, which is the 3 dots, drop the menu down, and click Admin Tech. The optional command section allows admin to create downloadable troubleshooting files such as logs, cores, or tech outputs that can be used for finding issues or be sent to the TAC. In the Generate Admin Tech File pop-up, you can select which of the 3 types of file you wish to download. In this case, I chose all 3 of them, and I'm going to click Generate. Now it tells you where to go find the files if you close the pop-up window before it finishes generating, but if you sit here long enough, it will generate the files and this pop-up window will change and we'll have a download button on this pop-up window. Depending on which files you chose to download or generate and how much data is on the device will determine how long it takes to actually generate these files, so be patient. So now that we have the download button, we can click that download button and download the files to our local hard drive. The file will come down as a compressed file. You might have to uncompress it twice as I did, but it just depends on which machine and which extraction tool you're using to uncompress it. Now we have a folder with all of our files in it, and you can see that they're organized by the type of file that they have. If I come into this config directory, I can edit the config file and I'll see what the running config is on that device at the time that we generated these tech files. It's a good idea to generate these files for one of your devices and just take a look around and see what is in the various different files within the 4 different folders. And as I do at the end of each and every one of these videos, I show you how and where to get help with your SD-WAN POVs. The first place you always want to go is the SD-WAN communities page, which the POV team is trying to make your one-stop shop for everything SD-WAN POV. If the SD-WAN community page does not answer your questions, try asking questions in the SD-WAN POV certified WebEx teamspace. Every engineer that becomes certified gets added to this teamspace, so the more people that we get certified, the more qualified answers we will get from the teamspace. And we hope that you will start answering questions in the teamspace as soon as you become certified. And finally, there's the old school method of asking questions, and that is to send an email to sdwan-pov-community@cisco.com. As the engineers become certified, they will also be added to this email alias. Thank you for joining me for this POV video nugget, and I look forward to seeing you for future videos. This is Paul Stryer. Have a good day.